Okay, everybody. So this is a different approach to way to go through the example. So previously I used the textbook and I wrote over it. This one I'm going to handwrite out the solution. Tell me if you prefer the way that I talked over example A or the way I'm going to talk through example B. So example B is page 44, and the problem looks like it's not obvious, is it? So they're equilateral triangles. I don't know if it tells me that somewhere. Determine the forces. Okay. Determine the forces on this framework. Cut through the isolated framework, and it is on page 44, not telling me what the geometry is, although they do give me a trig geometry at the bottom of the page. So working out from that, we've got a geometry of 3 equilateral triangles. Like that. And the side of these triangles is 3 meters. Obviously the internal angles is all going to be 60. We're going to take a cut through here. The members that we're cutting through, we'll label them up. So that's, or the nodes rather, B, C, G, G, and F. Okay, I'm going to throw away the left-hand side of my framework. The reactions we have are 60 and 30, and the load we have is 90. So throwing away the left hand side, so what does that leave me? Right, so what do I see on the right? So you draw out your framework, and then you imagine your members being a little bit cut, and then those members that have been a little bit cut, you make them into forces, and we're going to use the letters to make the forces. So I'm going to have I'm going to have a BC. Now the book uses different convention to me. I would call this force CG myself, but the book is saying GC. And this one is, they're saying GF. So I'm following the book. Okay, my convention is use the lower letter first, but it doesn't matter. We've got to keep our external forces on this side, so we've got a 60 and we've got a 90. Remember, these are all going to be 60 degrees. That's going to be 6 degrees, so is that. And the next thing that I want to do is to get rid of GC pointing out into space in an arbitrary direction. So I want it to be pointing so that it can be split up into a Y component and an X component. Okay, so let's do that next. So we have a triangle here. We've got our 60 and our 90. We've got this top one, which is the BC. We've got the bottom bar, which is the GF. And if we are going to use, say, theta is this side, so that's going to be 3 meters on that long side. That's been split into half, 1.5 that side. So let's use Pythagoras to work out what this length is. So that would be, if I call this h, we can then do 3 squared equals 1.5 squared plus h squared. Rearrange that, and then you're going to find that h equals 6.75 square root. I'm going to use hardcore mathematics on this. So that's what we're trying to do, is split up this GC. So resolve it through cos theta. So that's GC times by cos theta. And the other one will be the opposite of a cos. So that's the GC sine theta. Will be going upwards like that. Okay. Now we could use our triangle and work out some trig here. So we can go cos theta is 1.5 divided by its hypotenuse, which is 3. So that will be a half. And sine theta will be root 6.75 divided by 3. And a good thing to do there, I think, would be to stick into your calculator and see what you get. Let's see what the calculator, if it ties it up for us. So root 6.75 divided by 3. Yeah, tidies it up to being root 3 over 2. Okay. So I could then redo this. So we've got BC going in this direction. We've got GC times sine theta, but sine theta is root 3 over 2, so that's root 3 over 2 GC. And what about this one here going off in that direction? Cos theta is a half. Okay, so we've got half GC. And then we've got the other force here, which is GF. Let's not lose our external forces. So we've got 90 kilonewtons and 60 kilonewtons. Okay. Now in the book they resolve in the x direction, which I don't think is a sensible thing to do. I would skip ahead and I would either resolve in the y direction, because that's the only thing I've got pointing in the y direction, or I would take moments at whatever that joint is called. So that joint is the G joint. So I would do one or the other. If I take moments at G, then I'm going to find the BC. If I resolve in the y direction, I'm going to find the GC value. So I'm going to do slightly different to the book, and I'm going to resolve in the y direction. Okay, so let's go back to my diagram. What can we see going in the y direction? We've got 60 going up, 90 going down, root 3 divided by 2, GC going up. So we've got 60 going up, 90 going down, and then we've got root plus root 3 over 2 GC going up equals 0. So you can rearrange that, and you'll put that in your calculator, and you should find that GC equals 34.64 kilonewtons in tension. Okay, so the next stage is to take the moments around the G joint. So we're going to take moments at G, clockwise I think. I need to go back to our geometry. So from here to here is 6.75 square root. So that's the first moment I can see that's going clockwise, go around. So let's put the clock face on it. So we're going around and around. So BC is a positive moment, and also this 60 times this distance, which is 3 meters, is also going to be a positive moment. Okay, so we have BC times by root 67.5, and then we've also got plus 60 times 3 equals 0. Let's rearrange that. BC will then become, do a bit of fiddling, and you're going to end up with minus 180 divided by root 675. That's something you want to stick in your calculator. Maybe the calculator will work out what the rational numbers should be, but we want the final result, which is in decimals, and that is minus 69.28 kilonewtons. So therefore that one is going to be in compression. So the next stage I would do is resolve the forces all in the x direction. Okay. Go back to this diagram again. What can we see going in the x direction? Quite a lot of things. We've got the BC, we've got half GC, and we've got GF, but no external forces. Okay. So when we resolve stuff in the x direction, we've got the BC, start with that one, the half GC, and what was the other one? GF. Okay, we're looking for GF. So GF is going to be minus BC and minus 0.5 GC. Okay, so substitute those values in. We've got, and that will give us minus, so the BC value was, yeah, so minus 69.28. Okay, and then minus 0.5, and the GC value was 34.64. Okay, so let's find out what that is going to be. So we are going to end up with 69.28, take away 0.5 times by 34.64. Okay, and I get a different answer to the book. What have I done wrong? Probably on my calculator. Yes, I have. Yeah, so it's 51.96 kilonewtons. And in this case it's going to be in tension. Okay, so that's that done, so that's page 45 finished. Alright, so do you prefer me using a smart tablet board there, writing out the solution, or did you prefer me writing over the notes and discussing them? That's the question, please. Send me an email, tell me what you prefer.